Now that we have become familiar with what I like to call the mother functions of sine and cosine, we're going to discuss how to graph variations of sine and cosine. For example, if we shift it horizontally, if we shift it vertically, or if we do a shrink or a stretch. But before we do that, we need to talk about some basic terminology. First term that we need to know is what an amplitude is. If I look at the graph and I look at the center line that comes up through the middle, I like to call that the midline or the center. If I come out from the midline or from the center up to the maximum point or to the minimum point, the length of that line is my amplitude. So the length of this line or the length of this line is my amplitude. So in this case, with the mother function of sine, my amplitude is going to be 1. There's also something called the period. The period is the length of one complete cycle. If you notice, I can break this graph up into different pieces here. If I trace this graph from left to right, it goes up, it comes down, and it comes back up again. Then it repeats. It goes up, it comes down, and it comes back up again. If I keep doing that, this graph goes on forever in either direction, but the time it takes, or the length it takes for it to complete one full cycle, that length is called the period. And in this case, with the mother function of sine, it's 2 pi. Okay, now there's also something called a phase shift. This graph does not have a phase shift. However, if it did, the phase shift just means how far it's moved horizontally. It's just a fancy way of saying what the horizontal shift is. Okay, now I also like to label what I call the key points. I have, for each mother function, for sine and cosine, I have key points. I have 0, then pi over 2, then pi, 3 pi over 2, and then 2 pi. These are what I like to call the 5 key points. At 0, my sine function is 0. At pi over 2, my sine function is 1. At pi, the value of my function is back to 0 again. At 3 pi over 2, I'm at -1. And then at 2 pi, I come back up to 0 again. These are key points, and we're going to use those when we start graphing variations of sine and cosine. So these are your key points for sine. For cosine, your key points will be this. My x's will be the same. I'm going to start at 0, then pi over 2, then pi, then 3 pi over 2, and then 2 pi. However, for cosine, you're going to have different y values or different outputs. If I look at 0 on my graph of cosine, at 0, my value is 1. At pi over 2, my value is 0. At pi, my value is -1. At 3 pi over 2, my value is 0 again. And then at 2 pi, it comes back up to 1. Notice that if I look at one cycle of cosine, I like to point this out, one cycle, or the first cycle of cosine, looks like a bowl. And one cycle of sine looks like this. Okay, just to point that out for future reference. Okay, now, this is what your equations will look like for shifted sine and cosine functions. This is a shifted or translated sine function. And here's my shifted or translated cosine function. In both of these, A represents the amplitude, your period for a shifted trig function is going to be the period of your mother function divided by your value of B, which would be right here. Now, in this case, for both of them, sine and cosine, the period of my mother function before it gets translated, reflected, shifted, shrunk, or stretched, the period of the mother function is 2 pi. So the period of the new function is going to be 2 pi over whatever the value of B is. Okay, your phase shift, or your horizontal shift, is going to be the value that you get when you take C divided by B. And to figure out if it's shifted left or right, you have to look at this sign here. Plus means it's shifted to the left. Minus means it's shifted right. Okay, and lastly, if this is shifted vertically, that's going to be your value of D. If D is positive, then it's going to be shifted up. If D is negative, it's shifted down. Okay, we're going to go through some examples on how to graph translated sine and cosine functions. The first example, we're going to use y equals 2 sine 3x minus pi. Now, because I have sine here, I know my mother function is sine. So here are my key points for my mother function. And here's a graph, a sketch of my mother function sine x. So I start at 0, 0. That's this point here, 0, 0. Let me go through this in a different color so you can follow me. At 0, 0. Then at pi over 2, I go up to 1. And then at pi, I come down to 0. Then at 3 pi over 2, I come down to negative 1. And then 2 pi, I complete the cycle and go back up to 0. Notice that I have this broken up into 1, 2, 3, 4 intervals. That's going to play a part later when we're looking for scales so we can come up with our key points. Okay, so going back to our translated function, the first thing we want to find is our amplitude. Our amplitude is our value of A. So that means in this example, our translated function is going to have an amplitude of 2. If I look at my mother function, my amplitude is 1. I come up to 1 from the center or the midline, and I come down to 1 for my min and my max from the center or my midline. For a translated function, when we graph it, it should go all the way up to 2 for a max and all the way down to negative 2 for a max. Okay, the next thing we need to find is the period of our translated function. And in order to find the new period of a translated function, you look at the period of the mother function and divide by the value of b. Since the period of my mother function sine is 2 pi, I'm going to take 2 pi and divide by the value of b, which in this case is 3. So that means a full cycle for my translated function, this function 2 sine 3x minus pi, is going to be 2 pi over 3. That's the length of one full cycle. The next thing we need to find is the phase shift. Okay, that's my horizontal shift. Since we have a minus here in my formula, that means it's going to be a shift to the right. So in order to find how much it shifts though to the right, you need to take your value of c, which in this case is pi, and divide by the value of b, which is 3. So if we look at our mother function, our first cycle starts at 0. Since our translated function has shifted right pi over 3, we are going to start our cycle at pi over 3. Now, here's where we need to find our scale. I want to break up my length or my cycle into 4 chunks so I can find each of those 5 key points. So, to find the 4 intervals, or to find the length of each of those 4 intervals, I take the full length of the period, which is 2 pi over 3, and I divide by 4. Remember, when you divide and you're dealing with fractions, you change the division to multiplication, and you multiply by the reciprocal of the second value. So you take 2 pi over 3 times 1/4, and you get 2 pi over 12, which is pi over 6. Okay, so what that means is each of these intervals, when I draw my translated function, each of those intervals should have a length of pi over 6. So I'm going to start at pi over 3. Since I usually start at 0, 0 for my mother function, but I'm shifted right pi over 3, that's my new starting point. So I start at pi over 3. Then to get my next point in that interval of the translated function, I have to add pi over 6. Each interval is worth pi over 6, or a length of pi over 6. So when I take pi over 3 and I add pi over 6 to get my next point, that gives me pi over 2. Then if I add pi over 6 again, that gives me 2 pi over 3. If I add pi over 6 again, that gives me 5 pi over 6. And if I add pi over 6 one more time, that gives me pi. So my starting point for my new cycle, for my translated function, is pi over 3. My last point of my cycle is going to be pi. So the length of this cycle, we should say that that's the length of the period. And from pi over 3 to pi, that's the length of 2 pi over 3. So that makes sense. That should be the length of my period. So I found my key points for x, for my input. Now, for my output, they're almost always going to be the same as these, except for maybe the amplitude. So typically, we start at 0. The next key point is your maximum. Because I have an amplitude of 2 for my translated function, it's not going to go up to 1, it's going to go all the way up to 2. So at pi over 2 for my new function, I should have 2. The next point should come back down to the x-axis again at 0. The next point should be my minimum. In this case, -2, because my amplitude is 2. And then lastly, I come back down to the x-axis again, which is 0. So these are my points that I'm going to plot for our translated function 2 sine 3x minus pi. Okay, so these are my points for my translated function. So I'm going to break this up. All the way out here will be 2 pi. This will be pi. Then I break that in half. That'll be pi over 2. This will be 3 pi over 2. Then I break this in half. That's going to be pi over 4. 3 pi over 4. That's going to be 5 pi over 4. 7 pi over 4. So we have this scaled. Okay. My mother function, sine x, typically starts here. At pi over 2, I reach my maximum at 1. Then at pi, I come back down to 0. Then at 3 pi over 2, I'm at -1. And then at 2 pi, I come back up to 0 again. So this is my mother function, sine x in red. Our new function, I'll do that in green. That was y is equal to 2 sine 3x minus pi. Okay, that's these points right here, my new function. Okay, so at pi over 3, I'm going to plot 0. Pi over 3 is a little bit after pi over 4, between pi over 4 and pi over 2. So around here somewhere. Then at pi over 2, I go all the way up to 2 because I have an amplitude of 2. At 2 pi over 3, which is in here somewhere, a little bit before 3 pi over 4, I come back down to 0. At 5 pi over 6, which is a little bit before pi, I come down to -2. And then at pi, I come back up to 0. So here's my period that has a length of 2 pi over 3. My amplitude is 2. That's the height from the midline out, if you compare it. Now, if I look at my mother function, sine x, my amplitude is 1. I come up to 1 for my max and my min from the midline. And the period for my mother function sine is 2 pi. So you can see the differences in the graph and how it's been horizontally compressed and then vertically stretched. Okay, here's our second example that we're going to graph. Here's our translated function. If you notice, this is a cosine function. So when we look at the mother function, we're going to be looking at cosine x. So here are the points for our mother function. And when we graph our mother function, it looks like a bowl if we look at just the first cycle from 0 to 2 pi. Okay, so when we go look at our translated function, the first thing we need to find is the amplitude. The amplitude is our value of a, and that tells you from the midline or the center of your graph how high up you go or how low you go from that center. Our value of a is 5, so that means from the center I'm going to come up 5 and go down 5 for our max and our min points. Okay, the next thing we want to find is our period. To find the period of a translated function, we take the period of the mother function and divide by the value of b. Since our mother function is cosine, in the period of our cosine is 2 pi, I'm going to take 2 pi divided by b. In this case, our b is pi. So that means our period is 2. So one complete cycle of our translated function is going to have a length of 2. The next thing we find is our phase shift. That tells us how we're horizontally being shifted. Because this has a plus here, that means I'm going to go to the left. And then to find how far we move to the left, I take my value of c, which is pi over 2, divide by my value of b, which is pi. So I take pi over 2 and I divide by pi, and that gives me 1/2. So that means instead of starting at the point 0, like my mother function starts at 0, we are going to start by shifting left 1/2. So when I start writing down my points, if I usually start at 0, but I shift to the left 1/2, my new starting point is going to be -1/2. Now I got to figure out how to scale this. One complete cycle for this translated function is 2, and I want to split this into 4 chunks so I can find my 5 key points. So I'm going to take the length of my period and divide by 4 to figure out how I should scale this. So 2 over 4 is 1/2. So that means I have to keep adding 1/2 to get my key points. So -1/2, if I add 1/2, that's going to give me 0. Then if I add 1/2 again, that's going to give me 1/2. If I add 1/2 again, that's going to give me 1. And then if I add 1/2 one more time, that's going to give me 1.5 or 1.5. So there are my key x values. Now I got to find my y values. Typically, cosine starts at 1, my maximum point. Since we have an amplitude of 5 for our translated function, we're going to start at a maximum point of 5. Then cosine for the next point goes back down to the x-axis, so this is going to be 0. Then for the next point, the center point, we dip down to the minimum point. Because our amplitude is 5, that's going to be dipped down all the way to -5. Then we come back up to the x-axis, which is 0. And then lastly, we come back up to our maximum point, which in this case is 5. So here are the points that I need to use to graph my translated function. Okay, now let's draw the graph. Okay, so I've got it scaled. I need to come up to 5 since I know my maximum point is 5. And I need to come down to -5. Okay, so when I plot -1/2, I have to start at my highest point. Let's do this in a different color so it's easier to see. Then at 0, I have 0. Then at 1/2, I'm all the way down to -5. And then at 1, I come back up to 0. And then at 1.5, I come back up to my maximum point. So I still have that bowl shape. It's just a little bit taller and a little bit skinnier than the mother function. Okay, for example 3, we're going to graph the translated function -3 cosine 2x minus pi over 2. Now, something different than what we've talked about in the 2 previous examples, notice that there's a negative in front of our 3. Now, in college algebra, we talked about if a negative is in front of the function, that means there's going to be a reflection. And the reflection is going to be over the x-axis. So if I want to graph the mother function, y equals cosine of x, here it is right here. Okay, it starts at 1, then it goes to 0, then it goes to -1, then 0, and then back up to 1 again, and it looks like a bowl. If I draw the reflection over the x-axis and draw minus cosine of x, it's going to look like this. instead of having a maximum at 1 to start off, I'm going to start off with my minimum, because now it's going to look like an upside down bowl, and it's going to look like this because it's been flipped over the x-axis. So when we come up with our key points for the translated function, what that means is instead of having a maximum point to start off with, we're going to start off with our minimum point because it's been flipped. Okay, so we need to find our amplitude. Our amplitude is 3, so from the center or the midline out, it's going to go up to 3. For our period, we take the period of our mother function, and our mother function is cosine, and we divide by our value of b. Since our cosine has a period of 2 pi, I take 2 pi and divide by my b, which is 2. So the period of my translated function is going to be pi. So instead of going out to 2 pi or having a length of 2 pi, our period of our translated function is going to be pi. It's going to be half the distance for one cycle. Okay, now we find our phase shift. Notice that we have a minus here. That means I'm going to go to the right. And to find how far I get shifted to the right, I take my value of c over b. c is pi over 2, and b is 2. So I'm going to shift pi over 4. So that means I'm going to shift right pi over 4. So my starting point for x, or my independent variable, is going to be pi over 4. For my scale, my length of my period is pi, and I want to break that up into 4 equal intervals. So I'm going to take pi divided by 4. So as I find my key points, I'm going to keep adding pi over 4. Okay, so we have a phase shift to the right, pi over 4. So instead of starting at 0, we're going to start at pi over 4. Then I have to add, since my scale is pi over 4, add pi over 4 to pi over 4, and I get pi over 2. When I add pi over 4 again, I get 3 pi over 4. When I add pi over 4 again, I get pi. And when I add pi over 4 one more time to get my 5th point, that's going to give me 5 pi over 4. Now, to find my corresponding y values, remember, here are the points for my mother function before it's been translated, and because it's shifted upside down, my mins and maxes get swapped. Okay, so normally we would start with our max, but because there's a negative in front here, it's been flipped upside down, so I'm going to start at the min. And since I have an amplitude of 3, it's going to be stretched down to 3. So I'm going to start at minus 3. Then I'm going to go to 0. Then typically for the mother function, you would go down to your min, but because it's flipped upside down, halfway point should be my max now. So that should be 3. Then I go back to 0. And then typically we would end with our max, but because it was flipped upside down, I should end with my min, which is minus 3. So here are the points for my translated function that we're going to use to graph it. Okay, so using these points, okay, so we have pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. All right, so at pi over 4, we're going to dip down to negative 3. At pi over 2, we're going to come back up to 0. At 3 pi over 4, we're going to come up to 3. Then at pi down to 0. And then at 5 pi over 4, back down to -3. So here's our translated, whoops, I'm not drawing that very well. There's our translated function. I can draw my mother function, cosine x, and we can compare it. For cosine x, at 0, we would start at 1. Then, at pi over 2, it would be 0. Then at pi, it would be down to -1. Then at 3 pi over 2, back to 0. And then at 2 pi, back up to 1. So here's my typical bowl shape. But because I had a negative in front of my original or my translated function, it's flipped upside down. And then also it got compressed in, so it's half the period. This period for my mother function is 2 pi. It has a length of 2 pi for my period. For my translated function, it's half that distance. It's pi. And then on top of the fact that it's half the distance, it's been shifted. Instead of starting at 0, it's been shifted so that it starts at pi over 4. Okay, our last example. Notice that our value for C in this example is 0. So we have a B is 1/2. We have our A is 4, but C is 0. All right, so we're going to first start off by finding our amplitude. Our amplitude is our value of A, which is 4, which means from the midline out, I'm going to go up 4 and down 4 in either direction to get our max and our min. Next thing we need to do is find our period. Our period is the period of the mother function divided by our value of B. That gives us the period of our new translated function. Since the period of sine is 2 pi, and then our value of B is 1/2, to find the period of our translated function, I take 2 pi divided by 1/2, which gives me 4 pi. So this period gets stretched out. All the other periods so far that we've looked at have shrunk down from the original period from the mother function. This one is going from 2 pi and it's getting stretched out twice as big or twice as long. Our phase shift is our value of C over B. And in this case, since C is 0, I have C over 1/2, which is 0. This tells me that there's no horizontal shift. It's still going to start at x equals 0. Okay, the last thing is to scale. To find my key points, I want to break up my entire length of my period into 4 equal chunks. So the length of my period is 4 pi, and I want to divide that into 4 equal chunks. So that's pi. So I'm going to start at 0 since there's no phase shift here. And then I'm going to keep adding pi to get my key points. So my second key point is pi, then 2 pi, then 3 pi, and then 4 pi. So I start at 0, I go to 4 pi, and I break it up into intervals of pi. Now, since there's no reflection, what I'm going to do is we would start at 0, then we go to our maximum point for sine for the mother function. You start at 0, you come up to your maximum point, then you come down to your minimum and back up to 0 again. So in this case, since my amplitude is 4, I'm going to come up to my maximum, which normally on the mother function is 1, but because I have an amplitude of 4, this is going to be 4. then the center point is going to come back down to the x-axis and give me 0. And then I'm going to come down to my minimum point, which in this case, since my amplitude is 4, I'm going to come down to -4. And then I'm going to come back up to the x-axis. Okay, but we are still not done. We've got one more step. These points right here represent the graph of this. Notice that I have a +1 here. That means I have to shift it up 1 unit. So I'm not completely done. I have to make one more chart, or I could cross these points off and just add 1 to them. Since this is going to be a vertical shift up 1, 0 is now going to become 1. 4 is now going to become 5. 0 will become 1. -4 is going to become -3. And 0 is going to become 1. So now these are the points. Now we're completely done because we had to remember to include that vertical shift up. Okay, so let's plot our points. At 0, I start at 1. At pi, I go up to 5. At 2 pi, I'm up at 1. At 3 pi, I'm down to -3. And then at 4 pi, back up at 1 again. So here's one cycle of my translated graph. Normally, my midline is on the x-axis. However, in this case, since it's shifted up 1, my midline is now y equals 1. I still have an amplitude of 4. From my midline or my center out is 4. From my midline and my center down is also 4. So my amplitude is still 4. Everything has just been shifted up 1. Now, if we compare this to our mother function, I would start at 0. At pi over 2, I would come up at 1. At pi, I come back down to 0. Then at 3 pi over 2, I'm down at -1. And then at 2 pi, when I complete my first cycle, I go back up to 1. So here's my mother function. You can see that my mother function has a period of 2, or a length of 2 pi. And then my translated function has a period, or a length of one cycle of 4 pi. So it's been stretched out and doubled.